Okay, so this is free response review, question number 28, and we have a two-block system again. Right now, it's frictionless, so we need to, let's look at some of the forces that we have and things that we know. We are going to make acceleration or motion positive going clockwise. On here, I'm just going to sketch out real quick the things I know. I have a normal force. I'm going to have weight going down, and then I've got a tension force on this first block going this way. And then on the block hanging, I'm just going to have a tension force, which I know is going to be equal to that tension force. And then we have force of gravity or weight pulling it down. So if we go to our free body diagrams, here we draw these out quick. We would have our normal force perpendicular, our tension, and then straight down we would have mass and gravity. Block 2, I would have my tension and my mass 2 and gravity. Remember, you cannot write out the components on our force diagrams for the exam, so I leave it like this. But I do know down here, I am going to make my axis. I'm going to tilt it. So I'm going to tilt it like this. So I am going to have a portion of my mass 1 and gravity. And since that's the attached, there's my cosine. And then this will be the portion in the x direction, and that's going to be the sine since it's the opposite. And I'm going to use that information now when I draw out my sum of forces. So for block 1, my sum of forces is in the x direction. It's going to be F of t minus the portion that is gravity, and that one was sine, and that is equal to the mass of that first one and acceleration. And what we're looking for is that right there. I'm looking for the acceleration of the block. And we know the acceleration for this block has to be the same as the block there. I'm going to need more information because I have a couple unknowns. So sum of the forces for my block 2 is going to be a negative force because we're going clockwise. This way was positive and this way is positive because we're going counterclockwise. So it's a negative force of tension here plus the mass of the second one times gravity, the mass of the second one, and acceleration, which again is what I'm looking for. I am going to rewrite this solving for tension because I know my two tensions are equal to each other. So if I rewrite this equation solving for tension, I'm going to have that. Over here, I'm going to do the same thing. So if I put those two equal to each other, I am going to have mass 1, the acceleration, mass 1 times gravity. The sine is equal to mass 2 of the gravity minus mass 2 of the acceleration. Now it's just algebra time. And again, remember, I'm looking for acceleration. So I'm going to get my accelerations on the same side. And move my other ones to the other side. Keeping track of my negative values as I go along. Acceleration, I'm going to pull out. And I'm going to pull out my gravity just because it looks nicer. It's more concise. If I have to solve for it later, I would have less numbers I need to keep track of. And solving for acceleration is what they ask for. And divide that by the two masses added together. So it's just an algebra problem at that point. Next, we are going to make it a little more interesting. Is for the first time, we're adding in the coefficient of kinetic friction, which I know is just as used to K. And I know at some point I have to use my kinetic friction, F of K, is equal to that kinetic coefficient times the normal force. So I'm just going to put that in my back pocket, knowing that I'm going to have to use that sometime. And my free body diagram does change a little bit. I now have added in, I still have my F of T, but opposing it is my kinetic friction. And I know I have movement because it's kinetic. So this can't be greater than my F of T. That vector can't be greater because it is moving. I still have my normal force. And I still have going straight down mass 1 times g. So really I've just added in one more variable to my situation. So let's go back to block 1 and let's sum the forces in the x direction. And again, y going up is positive, and we decided we're going clockwise. So x is positive going that way. So I will have my tension minus my coefficient of friction and still have mass times acceleration. Since it's kinetic, I can't get rid of my acceleration. We know that I have to take the normal force, the texture versus how much it's pushing down. So this will keep expanding out. Oh, I forgot a force. Remember, I still had to break down this to there, so I forgot mass times gravity, the sine of that, and it's negative because it's going against me, acceleration. So this now becomes I've got a whole lot of stuff in there. So to get the normal force, we know we're going to have to go to block 1 and sum up the forces in the y direction to get f of n. That's what I'm curious about, or I need to know to continue on with my problem. So I've got f of n is positive because it's going up, minus just this portion here, which we decided up here was the cosine. So I've got mass times gravity times the cosine of that. And there is no movement going in the y direction like that for this block particularly. So f of n is going to become and this was for block 1. Block 2, I am going to need this information, but nothing has changed for its situation here, and I already solved for it right here. So I know to make my problem quicker, and I need to save time, I'm going to be able to use the information I already solved up here. None of that is solved, and I'm going to have my tensions equal to each other at some point. So I'm going to need that information I solved from up above. I'm going to solve this one for block 1 with my friction now. Solve it for f of t. And f of n is this, so that's mass 1, gravity, the cosine, mass 1 times acceleration. Notice I'm keeping track of my little mass numbers to know which mass I'm talking about because I have a couple of them. My two tensions are equal to each other. So now it really becomes a big old algebra problem. Oops. This was minus up here. It wasn't equal. It was plus. Sorry. Not doing my algebra correctly. And it's just equal to the other side, which we had solved up above. I need to solve for, they wanted acceleration, so I am solving for those. So get all my accelerations on the same side. And I can pull out acceleration. Nothing, I can pull out gravity on all of those. So if I had to have variables or put numbers in later, I could make it way less writing and less chance of making mistakes by typing in that number again and again. So I'm going to pull it out. And I didn't move this down so you could see what I was doing. But there we go. So minus. And there we go.